Good afternoon, class. We are looking at pre-calculus practice test number 4, module 4, covering chapters 8 and 9. Chapter 8, application of trigs, polar coordinates and vectors. And now here's the second part of chapter 8, polar coordinates and vectors. We are covering polar coordinates, polar equations and graphs, polar form of a complex number, De Moivre's theorem, and vectors. So here's the second part. And again, reminding everyone, when you take an exam, you have to pledge that you are not getting any help from any source whatsoever. All right, so to continue what we started, given z equals 8, find the complex cube roots. Well, reminding everybody of some of the stuff we have seen, and this is if W is R cis theta, cosine, let's say theta sub 0, plus I sine theta sub 0, cis theta sub 0. When n is 2 or larger, there are n distinct complex nth roots of W. Z sub k is the nth root of A cis theta sub 0 over n plus 2 pi k over n, or you can go with 360 degrees times k over n. It depends whether you want to go with the degrees or radians. And k starts with 0 and goes all the way to n minus 1. So just for the sake of argument, if it's 5, so for example, cube root, that means 3 roots, 0, 1, 2, it stops at 2, because if you go with 3, it returns to the same spot again. So with that being the case, first and foremost, remember all real numbers, okay, whole numbers, basically they are the number times cis 0. So 8 is 8 cis 0, cosine 0 plus I sine 0, or 8 cis 0, or so forth. Sometimes they put the degree, sometimes they just mention 0. In this case, of course, this means radian, this means degrees. Okay, so if I have, just to remind everyone, if I have, let's say 12 is the same as 12 cis 0, because it's a real part. Okay, so the real part, that's how you get it quickly, and you can go back to the notes and see how we did that. So with that being the case, we are going to go with this formula. Let me erase my work. And so theta sub 0 refers to this angle, everybody. And again, we have two choices. We go with radians or degrees. Sometimes one may be easier than the other. Either way is fine. And so if we go with radians, 2k pi divided by 3. If we go with degrees, this is what we use. So instead of that, you can use that. Whatever is easier. So what is cube root of 8? Everybody knows it to be 2. And as I mentioned, because we want the cube root, k is z sub k here, is 0, 1, 2. Okay, and by the way, we don't want to mix these two. Perhaps we should change this to n. I don't want anybody to mix this up. This is different than that. Okay, n. It's an integer. Okay, that's an integer. All right. So if we put, so basically this goes away because it's 0. And you're dealing with this. When k is 0, you get 2 cis 0, right? This is what 2 cis 0. If k is 1, 2 cis 2 pi over 3. And if it's 2, 4 pi over 3. So those are the ones. Okay. So let's evaluate them for 0. By the way, 0 degrees or 0 radians makes no difference, class. They're the same. So cosine is 1, sine is 0, so you get 2, and you're done. When we go with 2 power 3, we are dealing with cosine of 2 power 3 and sine of 2 power 3. In both cases, reference arc is pi over 3, right? So cosine of pi over 3, okay, versus sine of pi over 3. So cosine of pi over 3, so this is 1/2 in the second quadrant. It's negative. This is square root of 3 over 2 in the second quadrant is also positive. You drop the 2, you get negative 1 plus I squared of 3. In this case, everybody, again, we have the same reference arc, the same value, but both sine and cosine are negative in the third quadrant. So this is minus 1/2. This is minus square root of 3 over 2. And if you multiply it by 2, this is what you get. Let me erase my work. So reminding you z is x plus y equals r c theta. This is r cosine theta plus I sine theta in general. R squared is x squared plus y squared. This is called the modulus or the magnitude of z. R is square root of x squared plus y squared. Tan theta is always y over x. And you must pay attention to the quadrant. You should always pay attention to the quadrant, everybody. The product, Z1, Z2, we multiply R1, R2, and then we add up their, um, angles. Z1 over Z2, R1 over R2, cis theta 1 minus theta 2, and De Moivre's theorem says if you have R cis theta and you want to raise it to the power of n, raise R to the power of n and cosine n theta and multiply the theta by n in essence, R cis n theta. All right, now let's switch gears. Vector V has initial point P and terminal point Q. Write V in forms of AI plus BJ. Find its position vector. Also find its magnitude. This is called the magnitude. P has coordinates 3, 2. Q has coordinates 5, 6. So let's go over the concept. So we have some point P1, some point P2 if you connect them. And this is the arrow referencing the initial versus the terminal point. Initial versus the terminal point. This vector, if you put it such that the initial point is at the origin, is called the position vector. And if I draw any vector parallel to those with the same size, same magnitude, they are identical. It doesn't matter where they are. So position vector V. If V, these are the components, vector A comma B is an algebraic vector whose initial point is at the origin, then V is called a position vector. So the initial point must be at the origin to be called the position vector. Algebraic vectors, there are two ways to write them. V equals AI plus BJ, or just put them in vector format A comma B. A and B are called components of the vector V. A vector with initial and terminal points x sub 1, y sub 1 is the initial, and q x sub 2, y sub 2 is the terminal point, is equal to position vector x sub 2 minus x sub 1, y sub 2 minus x sub 1. Y sub 2 minus y sub 1. So x sub 2 minus x sub 1, y sub 2 minus y sub 1. So with that being the case, let's do it here. So with that being the case, The x coordinate for this would be 5 minus 3, for this would be 6 minus 2, which is the vector with components 2, 4. Now, or we can write 2i plus 4j in the same manner, which makes it 5 minus 3 times I, 6 minus 2 times j, or just use this one and write 2i plus 4j. The I component along the x-axis, the j component along the y-axis. Magnitude. The magnitude of any vector is the square root of a squared plus b squared. Magnitude or the size. Okay. The magnitude is always non-negative. That means it could be 0 or positive. If the magnitude is 0, the vector must be a 0 vector. The magnitude of minus v and v are the same. If two vectors are opposite, in other words, if you look at this one, if I draw something parallel with the same size, but the opposite direction, everybody. Okay, this is the opposite of that, or that one makes no difference. They must have the same size. That's the because this is the modulus. And if you multiply it by a number, a or alpha is a number, then you can take it out as an absolute value in essence. So we want to find the magnitude of this or that, doesn't matter. So following this square root of a squared plus b squared, a is 2, so 2 squared, plus b is 4, 4 squared. They add up to 20, and 20 is 4 times 5, so 2 squared up. A quick recap so we can continue. When we use this notation, we are representing a vector with two components, the a component and the b component. The first component is along the x-axis, the second one is along the y-axis. We can represent it in this format, or ai plus bj. Any vector becomes a position factor, position vector if you move it such that the initial point is at the origin. That's it. And the magnitude, it really follows what we have seen before, the Pythagorean theorem, square root of a squared plus b squared. This is a component, this is the b component, okay? So Pythagorean theorem. So we are given the v and w. V is negative 2i plus 3j, and w is 5i minus 4j. We want to find the magnitude of v, v plus w, 2v minus 3w. And reminding you of what we said over there, what I want to explain here is very simple. If you want to add two vectors, let's say you want to add u plus v. So you put the initial point of the v to the terminal point of the u. So u, v, and this becomes u, v, u plus the v. Now you want to add w to that, okay? You put the initial point of w to the terminal point of their sum, u plus v. And now this one and this one. Now, how do you find the resultant? The initial of the very first to the terminal point of the very last vector. So first of all, the magnitude follows this formula. So we go back here, everybody. Negative 2 square it, 3 square it, under the radical, add them up. We get 4 and 9, and that's square root of 30. V plus W. Okay, let's add them up. And when you add up vectors, you add up the components. So this one and this one you add up. This one and this one you add up. So you get minus positive 3i minus j. It's very straightforward, everybody. Two v minus 3w. So 2 times, put the v here, minus 3 put the W here. Just the way you do addition and subtraction of numbers or variables in the same manner. So we're going to distribute. We get minus 4i plus 6j minus 15i plus 12j is to add up to negative 19i, and these two add up to 18j. Find the magnitude, direction angle, and a unit vector in the same direction for the vector v equals 3i plus 3j. So first and foremost, what we know, the magnitude follows square root of a squared plus b squared. So it's 3 squared plus 3 squared. See, a is 3, so is b. Again, just to remind you, you could see this in this format. And so this is 9 and 9, 18. And 18 is 9 times 2. 9 comes out as 3, and 2 remains. You always go with the exact answer unless otherwise mentioned. Now, the next one, so we got this. Then the next one discusses the direction angle. So what is the direction angle? So when you have a vector, everybody, it makes an angle of alpha with the positive side of the x-axis. Then we define v as the magnitude of v cosine alpha I plus sine alpha j. So the direction is alpha, where alpha is between 0 and 360 degrees. It's between the vector v and I, the ix, component, if you will, the x-axis, the positive x-axis. So with that being the case, we follow the methodology that we knew with to before. To find it, we have to go with tan of alpha is b over a. So b and a happen to be the same, and it is in the first quadrant. So v is 3i and 3j. So tan alpha is b over a. Okay, alpha is in the first quadrant. We can see that location is what you see. 3 over 3 is 1. If tangent is 1, then alpha must be tan inverse of 1, which is 45 degrees. Again, this is not 45 degrees, but this is a general. Okay, so that's how you find the angle. So what is the direction angle? The angle the vector makes with the positive side of the x-axis. So according to this formula, then v is this times cosine of this I plus sine of this j. So 3 squared of 2, cosine of what we just found, 45 degrees I, sine of 45 degrees j. Okay. And if you work it out, you will get 3i plus 3j class. This, obviously, if you plug in, cosine and sine are both square root of 2 over 2. If you work it out, you will get the same vector. And by the way, you can check your work. Now, the last thing here is a unit vector. The question is, what is a unit vector? So we know the magnitude, we know the direction angle, and now the unit vector. Unit vector in the direction of VU is the vector divided by its magnitude. Okay, so again, if V is AB, so A times the I would be the vector 1, 0, plus B times the J vector would be 0, 1. So this is the I vector. This is the J vector. And each one is a unit vector So this is a unit vector along the x-axis. The I is the unit vector along the x-axis. The j is the unit vector along the y-axis. So with that being the case, we are going to divide this by the magnitude. So we write the vector, and the magnitude, we've already found it to be 3 squared up 2. We separate it into 2 pieces, and we get 1 over square root of 2, or square root of 2 over 2. So we get square root of 2 over 2i plus square root of 2 over 2j. And by the way, to prove it's a unit vector, just square this one, square this one. This is a squared, this is b squared, must become 1. So basically, this is in the same direction as this one, but has a magnitude, specific magnitude, which is 1. Write the vector v in the form ai plus bj, given its magnitude and the angle alpha it makes with the positive x-axis. Also find the unit vector in the same direction for the vector and check its magnitude to be 1. And we know the given vector has a magnitude of 14. Alpha is 120 degrees. Reminding everyone of all of those, we are going to go with this piece. To first find the vector to do so. Magnitude is 14, and we're going to use 120 degrees, cosine of 120 degrees I, sine of 120 degrees J, and reference arc is 60 degrees. So cosine of 60 degrees is positive 1/2. Second quadrant makes it negative. Sine of 60 is square root of 3 over 2. Second quadrant sine is positive. 14 cancels out the 2, becomes 7. So we get minus 7i plus 7 square root of 3j. So that's the vector. And we did that because when we come up with the unit vector, that means we have to divide this by the magnitude 14. And so you can get rid of the 14. You can get rid of the 14 and change it to 2. This becomes -1. This becomes +1. And we end up with, I'm assuming this is a simple fraction you deal with, -1/2 I plus square root of 3 over 2j. Now, what happens is that this is in the same direction. So let's say this direction, right? Actually, this is 120, this direction. Same direction. In essence, this is the concept. So you have let's say this one makes it 120 degrees. Okay, let's make this 120 degrees. Okay, so if just making things up, you have to. So if this is the vector, now what we are saying is that this one is this portion of it, some portion. That's it. Why some portion? Because we want to limit this to a unit vector, which means the magnitude must be 1. That's the concept. Okay. And so having said that, how do you check? Well, square root of a squared plus b squared must be 1. So if you square this part and this part, this becomes 1/4, this becomes 3/4. It's 1 and square root of 1 is 1. This is how you check that it's a unit vector. Assuming everything is done right, this proves it's a unit. That's all it proves. This proves it is a unit vector. Okay. In what direction? Of course, we've worked it out in the same direction. Look at an application. A plane is flying at a speed of 200 miles per hour on a bearing of north, 55 degrees east. Remember, this is east, so 55 degrees east. That's the concept. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest nearest mile per hour, and the true course of the plane to the nearest tenth of a degree. So first and foremost, we are doing 200 miles per hour, north 55 east. So north 55 degrees east. So this is 55 degrees, everybody, which makes this angle 90 minus that, 35 degrees. So the magnitude is for this vector V A, V sub A, which is the velocity relative to air, by the way, V sub A, is this much, 200 miles per hour. And the angle is 35 degrees. So this is what we are dealing with, everybody. The wind is blowing from west to east, that way, 35 miles per hour. So this one has a magnitude of 35 miles per hour, and the angle, this is parallel to the x-axis. The angle is 0. So that means we are going this way. And this is the angle that it makes with the positive side of the x-axis. So this we call, so V, okay, velocity relative to air, velocity relative to the wind, and velocity. This is the true velocity with respect to the ground, everybody. So this one, we need this angle. Ground speed would be the magnitude of that, and the true course would be north, this angle, east, and this angle is how much? 90 minus theta. So we are looking for north, 90 minus theta. I hope everybody understands. This angle is 90 minus theta, east. So we need to find theta, and we'll be home free. So let's do that. they're going to add up. The components will add up. So we're going to write the components for this vector and for this one. So this one is 200 cosine of 35 degrees I plus sine of 35 degrees J, and cosine of 35 degrees is not a common R cube. Put it into a calculator, everybody. And it gives you this, the I component, the J component. This one, again, this is the magnitude, 35, the same thing. We are using this one, cosine of 0 degrees I, sine of 0 degrees J, sine is 0, cosine is 1, we get simply 35I. So this one is the sum of those two. So in order to add these two, you're going to add these two and you're going to add components, which means 163.83 and 35 is 198.33I. And this one doesn't have a J component, so this one. The magnitude for this, you square this one, you square this one. The magnitude is square root of A squared plus B squared. So this is A. This is A, everybody. This is B, A squared plus B squared under the radical. And you just put it into a calculator. It gives you 230 miles per hour, so you can check it out. Now, what about the tangent of alpha, the tangent of this angle? In essence, the tangent of theta is B over A, which is B 114.72 over A 198.83. And of course, you put this into a calculator. Theta is tan inverse of this number, gives you this, which is almost 30 degrees, 29.98 degrees. Therefore, you answer this as 230 miles per hour, north 60 degrees east. So pretty straightforward, everybody. A quick recap, so making sure everybody's following that. When a plane is doing 200 miles per hour in some direction with a bearing, with a specific bearing, in this case, north 55 degrees, and then the wind is blowing, will change both the speed and the direction. So this is the direction it's going, but the wind will change it to a new direction and a different velocity. That's the bottom line. So you find the components of the vector for the plane as it's flying and the wind, and then you add up their components, and it becomes the components of the new vector, the real, the ground speed, the real speed, if you will. The speed come in a, it depends on the framework compared to the ground. And so with that being the case, when you find those components, now the magnitude, you use square root of A squared plus B squared, and you use tan of alpha equals B over A to find the angle. And when you find the angle, you have the bearing as well, everybody. The dot product of two vectors has many applications with the following algebraic definition. Here's how it's defined. Vectors V and W. V is A1I plus B1J or A1B1. W is A2I plus B2J or A2B2. And alpha is just some number, a real number. Definition, V dot W is A1, A2 plus B1, B2. That's by definition, everybody. The symbol V dot W is read V dot W. The dot product is also known as the scalar product or the inner product. The result is a real number and not a vector. So you do the dot product for two vectors, you end up with the number. So properties of the dot product. V dot W and W dot V makes no difference. Order is not important. And I hope you see why it's not important. Take a look at this one. Change the order. Makes no difference. So put this one as the first vector, this one as the second vector. Okay. V dot 0 must become 0 because the 0 vector has component 0. V dot V, that results in the magnitude square. If you multiply the dot product by alpha, it's the same as alpha times V plus alpha times W. V dot W is A1, A2 or B plus B1, B2, which is the magnitude of V, magnitude of W, cosine theta. Angle between vectors. Cosine theta is V dot W, okay, divided by the product of the magnitude of V and W. And of course, V dot W, we can write A1, A2 plus B1, B2. And recall that the magnitude of V is squared of A1 squared plus B1 squared. Finding the dot product and the angle between A with components 4 comma negative 3 and B with components 1 comma 2. We just follow the formula. A1, A2 plus B1, B2, which means 4 times 1 plus negative 3 times 2. So multiply the first components, multiply the second components, add them up. This is 4 minus 6. They add up to negative 2. So that's the dot product. So that's this part. Now, the angle between them, plus V dot W is A1, A2 plus B1, B2. It is also equal to the magnitude of V times magnitude of W times cosine theta. So if you look at this part, if you divide by the magnitude of V times magnitude of W, the left side in this format or that format makes no difference, you get cosine theta. So we're going to write that. And by the way, let's graph him so you see what's happening, everybody. So go 4 units to the right, negative 3, 3 units down, and this would be 1. 1 and 2 units up. Okay, so that's 4 minus 3, and now connect them. This is the A, this is the B vector. Very straightforward. So we want to find this angle in between. That's what this second part is. They didn't ask us to graph, but it would be nice to graph and have a better idea. So we are going to go with this formula. V dot W, we already have the answer, negative 2. Now the magnitude of V, 4 squared and negative 3 quantity squared under the radical. For W, 1 squared plus 2 squared under the radical. So V and then W, the second one. Okay. I mean, for this, we could write plus. We could write instead of that A, B, magnitude of A times magnitude of B. That means the same thing. So this is 16 and 9. 25 comes out as 5, and this is 5 remaining inside. Negative 2 over 5 square root of 5. And if I rationalize it, get negative 2 square root of negative 2 square root of 5 over 25. Okay. So that's cosine theta. What is theta? Cosine inverse of this number. So you put this into cosine inverse, a calculator, and if we just stop there, 100.3 degrees is the angle between the two vectors. Finding the angle between two vectors show that the pair of vectors is orthogonal to I plus 3j and 6i minus 4j. I want to mention just orthogonal when it comes to vectors is, in essence, think about two lines being perpendicular. So that means the angle between them is 90 degrees. So this is the terminology used for vectors. Orthogonal vectors. Two vectors are orthogonal when the angle between them is a right angle, 90 degrees. The dot product of two orthogonal vectors is 0. Why is that? Because take a look at this one. What is the dot product? Magnitude of B, magnitude of W times cosine theta. What is cosine of power 2? 0. That's why if two vectors are orthogonal, their dot product must be 0. So we do the dot product. And to do the dot product, we multiply the components 2 by 6 plus 3 times negative 4. Okay, I'm using this part. So 2 times 6 and 3 times negative 4. This is positive 12. This is negative 12. They add up to 0. That's a proof. So orthogonal, think about it as perpendicular. The angle is power 2. Show that the two vectors are parallel, this one and this one. Well, what do we mean by parallel? Two vectors V and W are parallel when the angle between them is 0 degrees. Theta is 0, the vectors point in the same direction, or 180 degrees, or pi, the vectors point in opposite direction. In other words, V is alpha times W. One way to look at it, one easy way to look at it is that if you notice one is a multiple of the other, just notice if I multiply this by 2, this becomes 6i, this becomes minus 2j. So that is an absolute proof, and it's an easy one. Method 1, notice W is 2 times V, or V is half of W. And that's fine. So that's one way to do that, everybody. Uh, and that's a fast way, and you're done. The second method is to actually calculate cosine theta using this formula. And I want to show you how that works. V dot W. So 3 times 6 plus negative 1 times negative 2. The magnitude of V 3 squared plus negative 1 squared under the radical. W would be 6 squared and negative 2 squared under the radical. So I hope everybody can see what we are doing here. So 3 times 6, negative 1 times negative 2. This is 18, this is 2. This is 9 and 1, 10. This is 36 and 4, 40. So this becomes 20. The bottom is square root of 400, and I hope you know square root of 400 is 20. So that's 1. So if cosine theta is 1, theta must be cosine inverse of 1. What angle would that be? 0 degrees. They make a 0-degree angle. That's a proof that they are parallel. Parallel vectors, the angle between them is either 0 or pi 180 degrees. Find the vector projection of V, which is I plus 3j, onto W, which is I plus j. Decompose V into two vectors, V1 and V2, where V1 is parallel to W and V2 is orthogonal to W. That's the meaning of it. So let me show you a few pictures and then discuss the concept. And again, this is the dot product and so forth. Vector projection. The component of V along W may be found by projecting the endpoint of V onto the line L containing W. For this reason, the magnitude of V cosine theta is sometimes called the projection of V on W and is denoted by projection of V on W, a vector with magnitude of component of V on W, which is a scalar. V1 is a projection of V on W, which is V dot W over W squared. This is the magnitude of W times W. V2 is V minus V1, and component of V over W is the magnitude of that. Okay, so the magnitude of that, okay, comes the component. Now, what do we mean by that? Let's look at it. If you have this vector, most of the time we may be interested in components along the x and y axis. Notice if you think of this as the x axis. So how do you find that? If you drop a perpendicular, everybody, okay, this part and this part obey Pythagorean theorem. So V1, okay, so we are doing the vector projection into the x-axis in essence, whereas this one into the y-axis. And if you call this theta, okay, you know that cosine theta is the adjacent V1 over the hypotenuse, which we call it V. And so the product of these two becomes V1. And that's exactly what we are saying here as far as the magnitude. So really, it just follows uh, um, trigonometry too, in essence. And so if you, let me erase my box. So if you have this one, the component along the x-axis goes on the left side. Along the y-axis happen to be up there. If it's vector like that, then along the positive side of x. If it's like that, both of them are negative. Or it may be something completely different. In this case, this is the vector that is going towards the center of gravity. And so you have two components along the slope and one which is always perpendicular to that. I can't emphasize this enough, everybody. Always perpendicular to that, okay? So with that being the case, look at these two two tick marks is one. So two tick marks here for one. And 1, 2, 3, 4, 5, 6 tick marks for 3. So this in essence is 1, comma 3. Where is this one? 1, comma 1. So two tick marks along the x and y axis. Now, find the vector projection of this onto this. That means if you extend this, everybody, think about this one in essence as your, okay, let me erase more. Okay. Think of this one as your x-axis in essence, okay? So we want this one And then, so that's projection into that. And then this one. Okay, that's the meaning of it, everybody. So following that, V1 is projection of V onto W. So V dot W over W quantity squared W, which is the magnitude. And so this one is 1.3, this one is 1.1. So I want to make sure you see the point. And so following this, one times one, three times one. Please understand this is one times one. This is, maybe I write at top of it. It's one times one plus three times one. Okay, so it's very straightforward, everybody. And of course, square root of 2, squared is 2. So you get 4 over 2, which is 2, 2 times W. And replace it, you get 2I plus 2J, or 2 times I plus J, either way. So again, in essence, let me erase my work again. What you're looking for, some multiple of this, because you're projecting it into this as V1. And this will, this in essence is the magnitude of that, okay? Because I plus j is a unit vector, the magnitude of I plus j is 1, remember that. No, I mean I is 1, the magnitude of each one is 1. But actually the magnitude of I plus j is squared root of 2. Now, V2 is V minus V1. So this one, subtract this, which means minus 2I minus 2j. This one and this one, minus I. This one and this one, plus j. Okay. And so if you look at the result, see this is the V1 component, and this one is the V2 component. Find the work done in pushing an automobile along a level road from a point A to another point B 40 feet from A while exerting a constant force of 90 pounds. So we're going to go from point A to point B, and we're going to exert 90 pounds. What is work? And this is something from physics. Work is the result of force being applied to an object over some distance, which in turn may change the object's total energy. When the amount of force varies, we use calculus. Work equals force times distance, W equals FD. Force F equals MA, you may remember, or the weight is mg. So W, work is W is FD, so magnitude of F, magnitude of D, cosine theta. In this case, it is simply FD. So 90, F is 90, D is 40. You just multiply them and you get 3,600 foot-pound. That is the unit. By the way, uh, because they're going in the same direction, they make a zero angle, and therefore cosine of 0 is 1. That's why otherwise you have to. Magnitude of F is 90, magnitude of D is 40, and they make a 0-degree angle. By the way, just to give you a piece of information, joules, 1 joule is 1 Newton meter, 1 kilogram meter squared over second squared. Joule is defined as unit of work or energy in International System of Units, SI. It is equal to the work done by a force of 1 Newton when its point of application moves 1 meter in the direction of action of the force. And this is by James PreCalc joules. It equals 10 to the power of 7 ergs, and it's approximately 0.7377 foot-pounds, the relationship among them. But normally in science, we use the metric system or SI system. A child pulls a wagon with a force of 50 newtons. The handle of the wagon makes an angle of 30 degrees. With the ground, find the work done in moving a wagon 100 meters. And now the same stuff, the force is 50, the distance is 100, but theta is no longer 0, but rather 30 degrees, which means we have to use this one, everybody. We use this formula. And of course, theta is 30 degrees. Okay, so that is if we were pulling in the same direction without making any angle, then theta would be 0. So this is 50, this is 100, and cosine of 30 is square root of 3 over 2. So this is 5,000 divided by 2, 2,500 square root of 3 joules. And by the way, this is an exact answer. And now we are using the units of SI or metric system.